So my name is Tom Jebo, or Jebo, as you'd like to say it. I am with the Open Specifications Developer Support team, and our team helps our customers on the Office SharePoint Exchange link side implementing against the open specifications. So that's what I do every day. I also come here and do these kind of talks. Today I'd like to talk to you about these things. We'd like to first take a quick look at the Microsoft Office supported file formats. Take a look at the open specifications documents that are available to help you with your implementations. Look a little bit at some of the recent Microsoft Office interoperability changes that have been made and things that are happening in the interoperability world with third-party tools, and then go into an OXML deep dive. So when I say deep dive, it's going to be more like an overview and introduction, but we're going to actually take a look at some code, hopefully get into the code if I can move quickly through the slides here. And then after that, I'd like to just introduce a few troubleshooting tips that have come up recently with some of our new products, Word Online and things like that. So here we see the supported file formats. So we have, excuse me, we have the default file format for Office right now, for Office 2013, which is the OOXML format. And then, of course, the binary formats and the ODF and PDF and XPS. These are not all of the formats supported, but they are some of the top ones that are used, and of course the default one. If it seems like I'm going quickly through these, I am kind of going quickly through the slides so as not to cut into Chris's talk. So here we have the open specifications. I just wanted to introduce you to those. For those of you who haven't seen them or used them yet, the starting point, these are on the MSDN library. The link is right here. A good starting point for the open specifications is the OffDI document. This helps you if you are targeting word processing ML or targeting spreadsheet ML. This will help you, or even not ML if you're looking at binary file formats as well. This will help you figure out which documents. It'll actually tell you the set of documents that you'll be most interested in. And the documents are listed over here. So we have the standards. These are the open specifications that are related to the standards. I'll talk about those a little bit more as we get into them. But we also have the binary file formats. This is the legacy one. I'll talk about that briefly as well. And then a whole host of other specifications that help with Office implementations against our file format. So these are all file format related specifications here. And of course there are a lot of other specifications for SharePoint, Exchange, Link, and of course then there's the whole Windows side. But we're only concerned today with the file format specifications. And if you ever need help, if you ever need clarification, I think Miklos mentioned that he's worked with us before. He did a very good talk earlier today on what LibreOffice is doing. And if you ever need help, you can email us at dochelp.com, or you can go to the MSDN forums. There's community forums, and we monitor those as well. And my team of a very few people, about 4 people, will respond immediately within 24 hours, respond, acknowledge your request, and then get to work on getting you a clarification or an answer to help you with your implementation. So the binary formats, I just wanted to give one slide on this. The binary formats, these are the legacy formats. They're based on the compound file binary underlying format. Word, PowerPoint, and Excel put their binary structures and everything in streams and storages on top of those. These are all based on OLE, structured storage, something that I used to do a lot of. I don't do as much anymore because now we're doing XML based, but they are fully documented. So you can see all that here. It is not human readable. I would call it more geek readable. If you're able to read these, you definitely are a geek. And they're proprietary. They're not a standard. and of course very code-centric, not human-centric. So they're a little bit harder to deal with, but definitely they're fully documented, and if you need help with those as well, we're there for you. Okay. We also have full support for ODF. So this is a great thing. Just a few notes on that. I'm not going to talk about our ODF support in this talk, but just a few notes on that. Microsoft's been a member of the ODF Technical Committee since 2008. We introduced our support in 2007 SP2, Office 2007 SP2. We are currently in 2013 supporting the 1.2 version of ODF. And we have detailed implementation notes, quite detailed implementation notes in our open specs. So those are in the MS ODF 1 or 2, and MS ODF 3 open specifications. And we've also talked about these at our Plugfests as well when the support was new. So just a quick tour through some of the recent things that we've seen happen in file format interoperability. And I wanted to start out with just a little bit of a plug for the power of Office OpenXML, and we're going to go into this, and what is Office OpenXML and what does it look like. But just before we start and talk about the interoperability, the things that you're about to see, the stuff that Office can do and that other third-party products can do, are really a result of the ease of implementation because of the XML format and because of the Office OpenXML format. We've got a very powerful and full, complete specification and standard for all of the different markup, the elements and attributes that define the functionality for the Office products. We also have OXML has a very simple, easy to understand, very accessible zip-based, URI-based, part-based naming scheme for its packaging. That's part 2 of the standard, and I'll talk a little bit more about that later. And then the extensibility is very powerful. The fact that you can easily add functionality and extend the markup language and still be interoperable with the Microsoft Office products, and we'll actually see that in the demo if I can get to that in time. The code that we'll put together is going to use some of this MCE, Microsoft Compatibility and Extensibility. And there's also a blog, a really good blog by Doug Mayhew. It's fairly old. It's from 2010. It goes into the history behind the two, part 1 and 4, which are the strict markup and the transitional markup. And so it's something that's hard to do that kind of a history here in this kind of talk. But if you read the blog, you'll get a very good feel about why we had the transitional and why we have the strict formats. So here you can see, as a result of the power of the Office OpenXML and the completeness and the ease of implementation, you can see that we have high fidelity between, say, Word and LibreOffice, and these are the same document rendered in both, and it's not incredibly complex, but definitely you see very good fidelity between the two. As well, you see multiple different platforms being used here. The Word Online product, so that's the web-based product, saving the docx format, so it uses the same formats. The Android Office product and the iPhone iOS product. So just some examples of how this is reached across multiple platforms. Oops. Nope. And another thing, this is something that's been around for a little while, is the open save, the adding a place to Microsoft Office, so interoperating with third-party storage, back-end storage hosting, file hosting, and as you can see here, adding Dropbox and Google. These are examples, but other third-party hosting is available as well as part of Microsoft Office's save functionality. And then something we announced, or something that Dropbox announced, and we've been working with them, and it's just one example of the interoperability work we've been doing with third parties, is the web app integration. And they actually announced this back in the fall last year, and then finished most of it. They finished this like in the last month. So I wanted to show. Here we go. So this is the Dropbox website, and double-clicking or editing or viewing on this same document here, and you can see there's commenting, shared commenting, so there's some collaboration. And this is really just the viewer, so this was actually available previously. And you can see, you know, we've got where do you want to go today? You know, Zaragoza, it's fun. So we go into the editor, and now we're editing within the Word web app in Dropbox. So this is something that was recently finished. My team actually did some work with the Dropbox developers, helping them with the MS WAPI and MS FSS HTTP protocols to get this to get the implementation moving farther along and to get to this point. So this is a good example of some of our interoperability efforts with my support team. And then this is just another example of the cross-platform usage. So this is actually my phone. This is the phone I have here. It's an Android phone, and is opening up Office and then going to the Dropbox backend storage and opening up that exact same file. So just a few examples of what the interoperability with file formats has been, you know, how it's grown in Office. And then with this one, you might say, hey, I've already seen this slide. You have. I just wanted to show that this is all made possible not only by the standards and our implementation notes and our extensions and documenting them fully, allowing implementers to easily quickly get to the point where they can use our file formats, but also where they can interoperate with Microsoft Office web products and backend SharePoint, etc. And that's these protocols over here, WAPI and FSS HTTP. And actually, you'll see in I think there's a talk tomorrow where we'll talk about WAPI and FSS HTTP file sync and sharing. So these are the standards. Just a little more detail there about the joint technical committees within ISO. I'll give some history in just a moment on this, but basically this is just listing the origin of the standards and that they're XML based and where they live in ISO. And then recently, for this year, we've seen some revisions going through. Not all of them are complete, but there is on part 3, there is a revision that has been approved, so that name will change to 2015 instead of 2012. The most recent version is 2012 for most of the ISO 29500, which is the standard for Office OpenXML. So we'll see that change to 2015 this year. And then there's also some revisions going on right now in the standards body for ODF as well. Okay, good. So let's take a look at Office OpenXML and see what that's all about. So Office OpenXML is based on XML, which gives it some distinct advantages. It's human readable, which is great. Unlike the binary file formats, so it's a lot easier to work with. Troubleshooting is a lot easier with Office OpenXML, if you've ever tried to do binary troubleshooting. It's standardized, so that's great. So we're already based on a standard. Unicode, so gives it a universal applicability. And then it's because XML already has a lot of code base out there for processing, you know, it makes it a lot easier for implementers to get into this. OXML is defined as 3 different types of markup. It's spreadsheet, word processing, and presentation ML. It can be consumed by Microsoft Office and third parties, and it's of course zip-based, the OPC, I'll talk about that a little bit more, and then the extensions, XLS, DocX, and PPTX. So brief history, I won't go through all these points, but the highlights are in 2000, the first XML-based file format for Office was introduced. It was much more limited, didn't have a zip-based package, etc. It was missing some features. In 2006, the standard that we see today was submitted to ECMA, and then in 2008 also to ISO, and ISO approved it. So 2008 was the first version of the standard that we see today as Office OpenXML, and then the current version is 2012. The supported file format versions for the standard for Office OpenXML are listed here. This talks mainly about the transitional versus strict support. The transitional was for migration purposes. The strict support was the agreed upon and approved set of elements, markup elements, by the standards body. So it would be more widely accepted and applicable for third-party products and all products. So the 2013 version, which is the final standalone version of Office, can read and write the strict conformance. And I will spend a little bit more time on that in just a sec. So a quick tour of the format. Part 1 is the fundamentals. So this is all, if you go to the ISO website, you can download this for free. They're PDF files. Part 1 is the markup language, the fundamentals in the markup language. It's very large. It's about 5,000 pages or over 5,000 pages. There's an overview in section 8. And then it includes the 3 different markups plus the drawing markup. So it includes the DocX, XLSX, and PPTX. For each of these 3 markups, there are part summaries and packaging summaries, and then there are the actual reference materials for the elements and attributes. So the highlights for part 1 are listed here. I did this kind of as a reference for you guys, for people starting out. Going to, for example, for word processing ML, going to section 11.3.10 will get you to directly the document XML part within the package. How that's defined, what's in it, and that's generally what people want to start with when they're looking for a word processing document to extract text or pictures or whatever. This is kind of the starting point here. Also, section 17 contains body, paragraphs, and runs and things like that. So I just listed here the kind of the quick start guide for the part 1 of the standard. There are also schemas listed in 2 different forms: the RelaxNG and the W3C schema, which can be used for validation purposes. And then the primer is a really important section. This actually has quite a bit of good information to get you started on using the markup language. Just a note about strict conformance. This is actually defined in part 1. So if you're wondering, is a document conforming to the strict ML, this is how it's defined in part 1. Basically, it has to be an OPC package. That means a zip-based package defined by part 2. It has to conform to part 1, so it's kind of self-referential there. Has to be one of the 3 types of markup, and if it has to conform to MC, that's the Microsoft compatibility and extensibility, and after removing those extensions, it has to the document has to be validated successfully against the schemas, like in Appendix A. Okay. So part 2 is the packaging model. It's the Open Packaging Convention. Uses the Open Packaging Convention. It contains the definitions of what we're going to find, like content types. So we'll actually see what that looks like in just a moment. Each of the parts are addressed by URI naming schemes, like file, folder, type addressing, and and they have a type, so it could be just XML or it could be a JPEG, could be text, whatever it is. That's all defined in the content types part. And then the physical package is zip based. Okay. Part 3 is actually kind of an interesting part to me. I like this part. So this defines the extensibility. So this defines the way for consumers to be aware of new and benefit from new features and functions in the markup language. It also allows them to be unaware of them. So it allows a consumer to not understand new features in the markup language and also be unaware, but then what we call degrade gracefully. So be able to say, I don't know what this whole markup, say it's about mathematics or something, and then still be able to render the file in a meaningful way. So there are attributes in MCE that are used for this. They are the ignorable attribute, process content, and must understand. These are very interesting. The ignorable attribute just basically says, if I have a namespace that is something that I've added, that I've extended the markup language with, say a version of Word or a version of my own application, I'm going to put that namespace at the top, say the document element in the document part. And if I know that maybe other applications don't understand that, I can mark it as ignorable. That means that other applications don't have to even treat it as anything. Now they may not they may not preserve my markup, which is in that namespace, but they can at least ignore it. Process content says that this markup, that this namespace, the elements in this namespace that I've extended, can be treated as if they are outside of a section that is not understood. So say you have a section where the namespace of the elements is not understood, but there is something within that, there's a namespace used within that. It can be, if it has the process content, that means it can be treated as if it's outside that section and the other section didn't even exist. And then must understand just says that if the consumer doesn't understand this namespace, it has to throw an error. So that's a hard requirement on this, because otherwise the document presumably would not be meaningful. The alternate content is a very interesting construct. So this is basically a switch statement. The alternate content provides choices. So if a consumer doesn't understand, the producer can write an alternate content block like a switch, and if the consumer doesn't understand it, then it gives choices. So version 1 or version 3 of a namespace may be one choice, version 2 may be another choice, and so on, and until finally there's a default, which is the fallback. And so that would be the safe markup to use if you didn't understand any of the namespaces listed in the alternate content block. And then spreadsheet and presentation only have an extra construct called the ext list and ext, and this is actually intended to allow consumers and producers to consume a document that has a bunch of namespaces that have been extended, but also preserve them if they don't understand them. So Excel will read in, for example, Excel will read in your spreadsheet if it has a bunch of namespaces listed in the ext list. It will make sure that those elements get preserved, that they don't get taken out when it writes and saves the file again. And then, as I had mentioned, the transitional markup language, that's in part 4. And this is a superset of the strict markup language, and it does contain some elements that were intended to be sort of backward compatible with older versions of Microsoft Office, to allow the Microsoft Office versions to come up to the strict standard. So it is a superset. And it has just some additional elements and attributes in there, like the one I've listed here. It also has a complete namespace, for example, the vector ML, which is the drawing reference. In the strict standard, we only have the drawing ML, so we don't use the vector ML. Okay, and these are the supporting documents. I've already shown these, but MSOI 29500 is the supporting document, the implementation notes for the ISO 29500. And I think all these slides will be available. Is that right, Michael? Are these going to be available later? So if you guys are taking notes, you'll have access to all of these things. I know I put a lot of reference stuff in here. But OI 29500 are the implementation notes. So as I think Miklosha was saying, first approach is to use the standard, try to implement against it. If you have a question or a clarification that something doesn't look like, maybe Word isn't behaving the way it says in the standard, then go to this document here, MSOI 29500. That's your next line of attack. And if there are no notes in there that describe the behavior you're seeing, then you have other, you can do other research. You can call us or send an email to dochelp@microsoft.com. Okay? So the ODraw XML, DocX, and XLSX and PPTX ones that you see here are our extensions. Those aren't implementation notes, but they are extensions. So that's where new elements and attributes have been added. So these are things you will not find in the standard. Okay. And here's an example. Pretty good. Here's an example of word processing ML. So as you can see, it's very simple, straightforward, easy to read for the most part. There's a few things in there that are a little bit cryptic, but nothing like trying to figure out what a binary Word document looks like. You can see there's a document that's the top level element in the document XML part. The body, and then paragraphs, runs, and texts. It's pretty easy to tell what all these things are. Just a little side note here. So how do you actually look at these? Well, it should be somewhat self-explanatory, but I'll state it anyway. They're zip files, so you can just rename the file to zip. So if it's a docx, rename it to zip, and then you can open it in Windows Explorer. And then you'll see the full file structure. And here's an example. So I have a sample file called sample.docx, and I renamed it to sample.zip. And now you see the top level folder, and this is typically what you'll see in any of these MLs, any of these markup languages. You'll see content types. You'll see a top level with content types. There might be some other files, but basically the content types.xml part describes what's in each of the other parts. There'll be some other folders here. The rels folder, _rels folder, is a relationship folder. So whenever a part, an XML part, refers to another part or something outside of itself, there's a relationship ID, and that will be described within the rels part, and you go to the rels part and it'll tell you what that ID equates to. It could be a picture, it could be another XML part, and it'll give the full address for it or the relative address for it. And then if you dig down or drill down a little further into the Word part, you'll see the same kind of structure, but you'll see the additional parts. So here in the Word part, we have the document XML part, which is the main body. There's one of those in a Word file. And then you also have media where pictures live, and styles and settings and all kinds of things like that. Spreadsheet ML similarly looks fairly straightforward. Sheet data at the top, rows, cells, and values. There's a few tips and tricks here involved in these, but this is kind of an overview. Slide presentation. This is a slide XML, so Slides are generally made up of shapes. So what you see here is the p:/sp, that's a shape element. And then within the shape element you see a number of things, one of which is a text body. Within that is the a:, which is the drawing. It's a tag for the drawing namespace. And the drawing namespace has paragraphs and runs and things like that too. And then the drawing ML, there's a complete markup for the drawing ML used by all the other parts or all the other markup languages. Usually you'll see things like pictures and shapes and things. And then here we see the relationship, just an example of the relationship for a drawing for one of the pictures. Here the ID was 2. We went to the rels folder again, and that defined the ID 2 as being this path media image1.jpg. So it's pretty easy to get around these parts, which makes it a lot easier for implementers to come up with interoperable solutions. And another note is that Spreadsheet and Word Processing ML have their own drawing markup elements, kind of subsets, or not subsets, but separate smaller versions of drawing. And the reason they have these is because some drawing commands or some drawing elements don't make sense for everyone, but they make sense for a word processing document. For example, a picture maybe need to be anchored with text wrapping around it or something like that. And that's the kind of thing you'll find in the drawing ML that's in word processing ML and spreadsheet ML. So, how do we build an OXML document? Well, we could do it by hand. It is actually doable. Simple OXML documents can be built using a text editor, manually putting the XML parts in, typing them in. A little bit tedious. You just have to compress it, the structure, get the structure right and compress it. It is a little bit tedious, but it is doable. It's not like trying to put together a binary file. Better would be to use one of the packages that are available, like the OpenXML SDK, or maybe one of the open source packages like libopc. And so this contains OpenXML SDK, contains tools for doing validation, which we'll see in just a moment. And it also allows you to read the strict conformance OXML and also validate against different versions and support different versions of Office, including 2007, 2010, and 2013. Okay. So I did want to show you, now that we've gotten to this point, I did want to show you the code for doing something like this, a very simple set of code. And this is a small project that I created, and just a few lines of code here we can create a simple document. So as you see here, let me just expand this for you. Well, the first thing you'll notice at the top is we've got some using, so the document format .openxml packaging and word processing namespaces, and also the Windows base reference is needed here too. So you need to add the document format OpenXML reference and the Windows base reference before you can use any of these classes. And OpenXML SDK is of course freely downloadable. It's available online. So this is, so you guys can see this. Sorry. So just to kind of give you a quick tour, the word processing document class contains a create method. This is what we're doing here, giving it the arguments for our simple sample file. And that's just the name of the file, and then telling it that it's a word processing document. Very intuitive kind of classes and structures are all named pretty much the same as the elements are named. So we create a new document and we can pass it because of the variable argument list for these C# classes. We can pass in, you know, a whole structure here and create with basically one line, one very long line. We can create an entire document. So that's what we've done here. You see body, paragraph, run, and then another paragraph with a run and text, etc., etc. Okay. So I'm going to skip, because we're running a little low on time, I'm going to skip to final solution and show you what we can do with the alternate content. Because this is a little bit more interesting. So I've taken, in this code, I would actually take the sample document that I had and do some editing with the power of link right here. You can see these guys. Link is a very powerful tool within, or a very powerful structure within C# that you can use to filter and find elements within the word processing document. So what I've done here is I've opened the Word document package, and I've gone to the main document part and am looking for all the descendants that are runs that have texts, or that have text elements, and that have this particular piece of text in them code. So I'm actually just going through, pulling that stuff out, and I'm going to replace it in this code with some alternate content for my own namespace. So to give you like a brief what this looks like here, this is what the code looks like. It's not terribly complicated, but I've added here, we come down here, the alternate content blocks. And so I've built up sections of code for my namespace. I called it Jeeb's snippet or something like that. This is for a fictitious editor that I might have made, and we can take a look at what that looks like in the actual package. So just quickly here, open the file. Oops. Not new, open. And go to here. Okay, this is the OpenXML package editor in Visual Studio. It's a great tool. You can take a look at all the different parts. So if we go and look at the document XML part, this is what it looks like. And you'll see that my code is in here. All the XML that I added is in here, as well as the XML for the alternate content. So I've provided a choice. Notice the namespaces up at the top. I've got this one called Jeeb's Edit Snippets, okay, with a tag of S, and I've called it ignorable. So I've said if a consumer doesn't understand it, they can go ahead and ignore it. But I also have an alternate content block which says if the consumer doesn't understand, or does understand it, they can use this block right here. But if they don't understand it, they've got a fallback, which is a bunch of XML that's all strict and doesn't contain any extensions. And if I go and load this, you'll see that it does load into Word. Okay. And even in spite of spelling errors, I do have the fallback choice because Word didn't understand my namespace. So this is basically what it looks like. But it does load into Word, it does conform, and I can validate this using a few lines of code. I can just quickly show you that. And with these lines of code using the OpenXML Validator class, I can validate any document against Office. And I can actually pass it a parameter that'll say, is this, I want to validate against Office 2013, or I want to validate against Office 2010 or Office 2007. Okay, so back to the slide. Okay, and I'm almost done. So I wanted to talk about some troubleshooting tips. So my team deals with a lot of Office OpenXML files that come from our customers, and sometimes they say this won't open in Word, or it's crashing Word or something like that. Hopefully it's not crashing Word. So I just wanted to talk about the troubleshooting tips. For standalone Word, we can use the OpenXML SDK tool or package, and we can use the validation code in there. That really does help us. Sometimes that will identify the problem. Sometimes we have to go further and use diffing the parts against something that was saved with Word. So, for example, open a file that does work and save it, and then compare what the applicable parts look like. And often it boils down to a binary search, kind of narrowing it down until you find the part that's offending. Oops, wrong way. Okay, if the file opens in standalone Word but doesn't open in the Word Online, there's a few things you can do here which we've used recently that are very helpful. You can turn on Uls Logging, which is available in SharePoint and the web app server. So if it's not opening in Word Online and you have access to an on-prem web app server, you can turn on this logging with just these few commands, and there's a reference to the article on TechNet, and correlate using a fiddler trace, because this is all web app, Word's web app code, correlate that with the user session ID, and then there's a ULS viewer tool, which is very handy. Even though the ULS logs are text and you can process them with an editor, the viewer tool allows you to search. So you can correlate that session ID with the correlation ID in the logs, and now you can look for problems that the web app server had when loading the file. And this can actually point you directly to the problem. For example, in this, I've got the file here. So this is an example from a case that I worked on, and it's a little bit big, but you can see that the logs contain a bunch of different information, including the server, the product and category, which is really helpful to know what's going on when it's trying to open a file. And then you can see here the actual error that the web app server got. So, and then it also shows a stack trace as well. So this is a very, very useful tool. It also has a notification list. You can just hit this, and it'll take you right to the asserts, any messages or asserts, and this was the one that we had. So this actually identified a color scheme problem that we had in a file that would have taken me probably hours and hours to narrow down by using a binary search, but this went right to the heart of the problem quickly. Yeah. Okay, and so that's it. That's the end of my talk. Did anybody have any questions? Okay, thank you.